Okay, this is Andrew McNamer with part 2, the network manager. So the network manager on the client has a static net client and initiates the server port, which is the same server port on the server. Just do this side by side. So the server port matches, the net peer configuration string also matches, and we enable the discovery response message type so that when we send it to the server can send it back, and then they are connected. Client starts a new client based on the config, and then I use the known peer connection method because it was the cleanest and I like what it was doing. And then for initializing the server, we accept incoming connections, have a max number of connections because it can have more than one, and then do the same thing with the message type and do the port so the ports match. For process incoming, this is generally the same. Client connects for this via the server endpoint. When a discovery request message comes through, this also comes through on the server. The server will connect and then send a discovery response back. When the status changes, when it goes from disconnected to connected, it fires this, where it reads the message in, connection status, and then this is where our network issues are laid. So for the server, we have the same simulated loss as we do on the client. And then we also do our time sync message, which we'll get to later. Data just processes the message, and then all the other warnings we don't deal with. So in send message, they're almost exactly the same. We have a memory stream with a binary writer off the stream, and then we serialize it off of that writer, whatever the message was that came in. Create the message, write to the array, and then send the message off. The only difference on server is that we have to make sure the server is actually connected to a client or another network entity, and then it sends the message based on which connection out of the connection array. So because we're only doing one client, it's always going to be 0. If we had 2 clients, it would be 0 and 1 based on which client it was. Process message is the exact same. The way I did it is I read the incoming message bytes into an array, started a reader off of a new memory stream off of the bytes array, got the message queue manager, and then I wrote the type. When we get to serialize, I'll show it in the message one. But I wrote type at the very top. I serialized it first so that I could read it in off of the switch. And then I take the reader pointer and seek it back -4 bytes, or the in 32 size, off of where it's at, so that it puts it back at where it was before it read this. So I basically take the type, seek back to where it was, and then deserialize off of that. But deserialize depends on the type of movement message type. So we get the message from the pool based off of the data, deserialize it off of the reader, and then add it to the input queue. And that is for all the message types. And then the rest is off of, we'll get to the rest of the data later. So in game scene play, on both, we create the network manager. We're using it as a singleton, sorry. We initialize it on enter, and then we process incoming, and then it'll process the messages before the message queue, so it'll be able to put anything that it needs to in there as well. And that is the network manager, part 2.